Alright, let's go ahead and get started. We're going to do this lecture video on Lesson 2 measurements, and this is just going to be part 1 of Lesson 2 in this lecture video. I just want to remind you really quickly that as you watch this lecture video, please follow along with your study guide. Record all of your notes in your study guide. Draw diagrams or anything that you need in order to learn this material. You might even need to stop this lecture video to take some time to record notes in your study guide, and that's perfectly fine. Okay, let's get started. So we're going to start out with two important vocabulary words that you need to become very familiar with. The first one is quantitative observations. What does quantitative mean? Well, it's simply this. They are observations made using one or more of your 5 senses. And of course, you are very familiar with your senses, and you've been using your 5 senses since, well, when you were born. And that is, in fact, your 5 senses are an important observation tool that you use to learn about the world around you. Sight, touch, smell, taste, and hear. All of these we are going to use, well, maybe not so much taste. Tasting in chemistry is not always a good thing. But we are going to use these other 4 senses, at least, in order to make observations during our labs or experiments that we do in this class. And you're going to record those observations in your lab notebook. All right, the other word here is quantitative. All right, quantitative is denotes a measurement or a numerical observation. Now, quantitative observations are very common in chemistry. We're always making measurements, and so just like we'll record our qualitative observations in a lab, we will also record all of our quantitative observations as well, or our measurements. Alright, so let's talk a little bit more about measurements themselves. There are 3 things that must be included in every measurement. Of course, your quantitative observation, which is your numerical value. You need to record units with that numerical value. The unit lets us understand what type of measurement we're making. And then you need to record what is known as the uncertainty, which is recorded as a plus or minus value. Now, uncertainties exist in a measurement because the instrument or tool that you're using to make a measurement has some limitations in its precision. There's no such thing as a perfect instrument to measure something. So there always will be an error or an uncertainty. All right? Now, we will spend a lot more time talking about uncertainties and how we determine the uncertainty in a instrument a little bit later on in class and in lecture videos. All right? So for now, let's just go ahead and write out a measurement in a correct way. Let's say we're going to take and measure an object's mass. All right? And let's say that we place it on a balance, and that object reads that it has a mass of, say, 10 point, see if I can get that, 0.2 grams. All right, and we're going to put grams because that is a mass unit. All right, so 10.2 grams is the mass of this object. Now we got to add a plus or minus value, which is the uncertainty, and for now we're just going to say that that uncertainty is 0.1. All right, and so these are the correct, or is the correct way of writing a measurement that you need to record as we're doing a lab or some kind of activity that deals with measurements. All right. All right, so let's talk about the system that scientists use to make measurements. All right, The units used for scientific measurements are those of the metric system. The metric system was developed in France during the late 18th century and is really used as a system of measurement in most countries throughout the world today. The United States as a whole does not use the metric system, but certainly scientists in the United States do. And so this is the system that we will use and focus on quite a bit in this class. Alright, now, because the metric system is so important, scientists eventually got together and they adapted a kind of a derived system from the metric system called the SI system, and this is known as the International System of Units. And this system is adopted by the entire world as a measurement system that we can use to communicate all over the world, and so everyone is uniform. And so you're going to learn all the units of the SI system. This table here, which I need you to fill out, these are the fundamental SI units that we assign to different physical quantities that we measure. So for instance, mass, the SI unit would be the kilogram, and the abbreviation is kg. For length, it's the meter, abbreviation is m, time is the second, then temperature is Kelvin, and that's something that might be new to many of you. The amount of substance is known as the mole. No, not the furry animal that comes out of a hole. It's literally a unit of amount of substance, the mole. MOL is the abbreviation. The electric current is the amp, and the luminosity intensity is the candle. The ones that we focus on in chemistry is mass, length, time, temperature, and amount of substance. The last two we don't deal much with. Usually you come across them more in physics than anything else. Alright, I need you to know these fundamental SI units, so memorize them. Know them well. I will test you and quiz you on them. Alright, so let's dive a little bit more into the metric system. Now hopefully the metric system or the SI system you have spent many years doing in your different math classes or other science courses you've taken, and so hopefully this is somewhat of a review, but I want to point out some important parts. First of all, in the metric system or SI system, we assign base units. For instance, the base unit here, which I will highlight, is given a value of 1. In fact, all base units in the metric system have a value of 1. Let's take a moment and go ahead and list some of those base units so that you're familiar with them. We'll address these a lot as we get more into this. Okay, so for mass, the base unit is going to be the gram. So even though the fundamental SI unit is the kilogram, for the base unit in the metric system we use the gram. So the gram is a value of 1. Length is the meter, abbreviated as a small m. Time, base unit for time is the second, which is abbreviated as a small s. And then let's go ahead and use volume. And for volume, it's the liter, abbreviated as a big L, or a lot of times, which is probably more correct, is to use the cubic decimeter. See if I can squeeze this in. Decimeter. Oh, best I can squeeze that in. Okay. The cubic decimeter is abbreviated as dm with the cube there. Alright? So these are the base units. All of them equal a value of 1 for these particular quantities. Alright, so these other values are prefixes. And what a prefix does is it denotes a specific value of the base unit. So, for instance, kilo. Kilo means 1,000 base units. So if I have a kilo, then I have 1,000 of whatever base unit I'm looking at. So let's go with mass again. So again, the base unit for mass is the gram. So if I have what is known as a kilogram, then that means I have 1,000 grams. And so you can look at this as 1 gram is equal to 1,000 kilograms, because kilo means I have 1,000 base units. Alright, so what about like giga? Alright, what does giga mean here? Giga means I have 1 billion base units. So if I'm dealing again with mass, if I have a gigagram, it means I have 1 billion grams. Alright? What about mega here? Mega. What is mega? Well, mega is 1 million base units. So if let's turn to like meters, okay? So to length. So the base unit for length is the meter, which is equal to 1. So if I have a mega meter, that means I have 1 million meters. All right. What about some of these other units down here? Like, what about centai? Okay. Well, centai means 1/100th of a base unit. All right. So if I'm dealing with, let's say, meters again, so length, with length, the meter being the base unit, if I have basically working with centimeters, it would mean that it would take 100 centimeters to equal 1 meter. Alright? Milli. A milli is 1,000th. So in order to have a meter, it would require 1,000 millimeters to equal 1 meter. Alright? The same thing with mass. If I have it would take 1,000 milligrams to equal 1 gram. Alright? So these prefixes here are really important for you to know what their value is based on the base unit being 1. Alright? So you need to take some time before you come to class learning these prefixes, especially the ones that are bolded. Alright? And so let me erase all these. And I will highlight real quick the bolded ones. The kilo, of course the base unit, the deci, the centi, the milli, the micro, and the nano. These base units are what we use quite a bit in chemistry. Alright, so that is all I have for this lecture video, part 1. So feel free to go back and relook at this lecture video if you need to. Please study your notes very carefully and prepare for a quiz in class over this information.